This video looks at finding the distance of one lap on a running track. So first of all, recall that the circumference of a circle is 2 times pi times r, and we will approximate pi using 3.14 in our work in this video. So let's imagine I have a running track. I have two straightaways and I have two curves, and these curves in fact are semicircles. And our question is, how can I figure out the length of one lap? And we're talking about lane 1, the inside lane here. Let's assume the radius here of these semicircles is 25 yards, and let's assume the straightaways are 85 yards long. Well, before we work with numbers, let's think of the problem as pieces. And what do we have? Well, I have two semicircles. If I put the two semicircles together, I get a circle. So this is a circle with radius 25 yards. And in addition to the two circles, I have a straightaway that's 85 yards, and I have a second straightaway that's 85 yards. So the length of one lap, or the distance of one lap, is going to be the circumference plus two straightaways. Well, the circumference of a circle, recall, is 2 pi r. So in this case, we have 2 times pi times r. The radius is 25 here. That's my circumference, plus 2 times 85, because each straightaway is 85 yards. So I'm going to use now 3.14 for pi. So I have 2 times 3.14 times 25 plus 2 times 85. Now let's work to simplify. So 2 times 25 is 50, so I have 50 times 3.14, and 2 times 85 is 170. Well, off to the side here, 3.14 times 50. First row is all zeros. Add a placeholder 0 for the second row. 4 times 5 is 20. Carry to 2. 1 times 5 is 5, plus 2 is 7. 3 times 5 is 15. So now I add the columns, and I get 15700, but I have to move decimal point 2 places to the left, so I get 157. So this is going to be 157 plus 170. It should be 157. So one lap on this particular track is 327 yards. Now we can apply this to any track where actually we, instead of using specific values, we use variables. So we can come up with a formula for one lap on any running track where the curves, in fact, are semicircles. So not all tracks have semicircles. Some of them have ovals and they have little straightaways here in the turns, but many running tracks actually have semicircles for turns. So we'll call the radius of the turn r, and then the straightaway length is s. So coming down here then, you put the semicircles together to get a circle. It has radius r. Again, we're talking about the inside lane here. And then these straightaways are s. So the length of one lap, the formula, using r and s as our variables, is going to be the circumference of the circle, which is 2 pi r, plus 2s. So if I know the radius of the turns, and I have a track that has two straightaways and two semicircular curves, and I know the length of the straightaways, I can calculate the length of one lap using this formula. So if I know R and S, I can plug them in and I can find the length of one lap around a track. So let's just say R is 30 meters. Let's say S is 100 meters. So the length of one lap on this particular track would be 2 times pi times 30 plus 2 times 100. Well, we'll use 3.14 for pi, and 2 times 30 is 60, so that's 60 times 3.14 plus 200. And 3.14 times 60, first row is all zeros, and placeholder 0. Let's do the math. 4 times 6 is 24, carry a 2. 1 times 6 is 6, plus 2 is 8. 3 times 6 is 18. So get 188.40. So this is 188.4 or 40 plus 200. So 200, put a placeholder, put a decimal point behind a 200 plus 188.4, placeholder 0 there. Add these up, bring the decimal point straight down, and we know the length is 388.4 meters when the radius of the turns is 30 and the straightaways are 100 meters. And we can plug in any values we want for R and S and get the resulting length of the lap. This is why we have formulas, because all we have to do is change the values for R and S, and then we can directly calculate the values. And this concludes the video.